Ever wondered why data persistence in Kubernetes is crucial? It's like asking why we need a memory. Just as our memory allows us to retain and recall information, data persistence in Kubernetes allows data to survive even after the container it resides in ceases to exist. Now imagine, if we forget everything we learned every day, we would live in a constant state of confusion, right? Similarly, in the world of Kubernetes, data persistence is the brain that remembers. It ensures that even when a container goes down, the data doesn't disappear into a black hole. It's the gatekeeper that ensures that data lives on, to serve and fuel our applications continuously. Without data persistence, managing and maintaining data in a Kubernetes environment would be like trying to hold water in a sieve. It greatly influences the overall performance of applications, making it a vital cog in the Kubernetes machinery. So without data persistence, our Kubernetes applications would be in a world of chaos. Diving deeper, what is this data persistence in Kubernetes we're talking about? Think of Kubernetes as a bustling city and the pods as its citizens. Now, every citizen has a life cycle, they come and go. But what about their belongings, their data? They need a storage space, right? That's where Kubernetes volumes come in. They are the storage lockers, providing a way for pods to store data. Let's get into the nitty-gritty. When we talk about data persistence in Kubernetes, we're referring to the ability to retain data even after a pod has been terminated. This is crucial because by default, the data in a pod disappears when the pod goes away. That's like losing all your stuff every time you move houses. Not ideal, right? But with Kubernetes volumes, the data sticks around, ensuring that your application can pick up where it left off. Now, Kubernetes has a bit of a wardrobe when it comes to volumes. It's not one size fits all, and there are several types of volumes you can utilize depending on your specific needs. There's the EmptyDir volume, which is initially empty and created when a pod is assigned to a node. It's like a temporary storage space for a pod during its life cycle. Then, there's the HostPath volume, which mounts the file or directory from the host node's file system into your pod. This is like renting out a room in someone's house. And there's the PersistentVolumeClaim, which is a request for storage by a user. It's like buying your own house. But remember, each type of volume has its own use case, and it's important to choose the right one based on your application's requirements. So when we talk about data persistence in Kubernetes, we're really talking about providing a safe and resilient space for your data. It's about ensuring that the data outlives the pod and remains intact across pod life cycles. It's about giving your data a home in the bustling city of Kubernetes. In essence, data persistence in Kubernetes is all about ensuring data remains intact across pod life cycles using volumes. Now that we know what it is, how does data persistence actually happen in Kubernetes? Let's start with the creation of a volume. In Kubernetes, a volume is a directory, possibly with some data in it, which is accessible to the containers in a pod. It's created by specifying a volume type and providing a name in the pod specification file. The type of volume determines its underlying storage mechanism. It could be a simple directory on the host, or a network storage like NFS, or a cloud storage like AWS's EBS. Next, the volume is attached to a pod. This is done by declaring a volume mount in the container section of the pod spec. Here we specify the name of the volume and the path within the container where the volume should be mounted. Now the volume is accessible to the containers in the pod, and they can read from or write to it. Storing and retrieving data is the next step. Any data that a container writes to its file system is stored in the attached volume. This data persists across container restarts, ensuring it's not lost when the container goes down. When a new container comes up, it can simply read from the volume and pick up where the old one left off. But what happens when a pod is deleted? The volume is not automatically removed. Instead, it goes into a released state. It's no longer attached to the pod, but the data in it is still intact. This is where the cleanup process comes in. An administrator or a storage service can take over and decide what to do with the volume. They might choose to scrub the data and reuse the volume, or archive it for later use, or even delete it permanently. That's the beauty of data persistence in Kubernetes. It allows us to decouple data from the containers that produce or consume it. It ensures that our data is always there, safe and sound, even when containers come and go. That's how data persistence works in Kubernetes, ensuring our data is always secure and accessible. Let's wrap up with some key points about data persistence in Kubernetes. Firstly, we've learned that data persistence is a vital aspect of Kubernetes. It's the mechanism that allows data to survive beyond the lifespan of a single pod. making sure that your important information doesn't vanish when a pod goes down. Data persistence is like the backbone of your applications, ensuring the information remains intact and readily available for future use. Secondly, we dove into the world of volumes. Volumes are the fundamental building blocks of data persistence in Kubernetes. They provide the storage space where your data is kept, and they're tied to the life cycle of a pod. When a pod ceases to exist, the volume does too. However, the data within the volume can be preserved and made accessible to other pods. Volumes are like the memory banks of Kubernetes, holding onto your data and keeping it safe. Next, we explored the process of data storage and retrieval in Kubernetes. We learned that volumes are attached to pods, and it's within these volumes that data is stored. This data can then be accessed and manipulated by the containers within the pod. When the pod is deleted, the data remains in the volume and can be retrieved by a new pod. This process ensures that your data is always accessible, even when pods are constantly being created and destroyed. Lastly, we emphasize the versatility of Kubernetes volumes. With a variety of volume types to choose from, Kubernetes provides flexibility in how and where you store your data. Whether it's on a local disk, in a network storage system, or in the cloud, Kubernetes has a volume type to suit your needs. In conclusion, data persistence in Kubernetes is about more than just storing data. It's about ensuring that data is readily available, irrespective of the life cycle of your pods. It's about providing a stable and reliable environment for your applications to function, and it's about giving you the flexibility to store your data in a way that best suits your needs. Remember, understanding data persistence in Kubernetes is crucial to managing and maintaining your applications effectively. So keep exploring, keep learning,